Okay, so here's a video on a couple of the power problems from practice 6. Okay, these are kind of similar to some that are going to be on the test. All right, so make sure you know how to do them. All right, we'll do number 2 first. All right. Jill pulls on a rope to lift a 12-kilogram pail out of a well while the clumsy Jack watches. For a 10-meter segment of the lift, she lifts the bucket straight up at a constant speed. How much power is required to complete this task in 5 seconds? Okay, so just to keep it simple, right, every single thing that we have that is lifting, you're going to do the same way. Okay, so this is an incredibly important problem I would make sure that you know how to do before the test. Okay, all right, so she's going to be lifting up this pail. Okay, it's going to lift up by 10 meters. Okay, and the pail has a mass of 12 kilograms. All right, so every single problem that's like this, that's something lifting, the only thing we're going to worry about is the EG, right? Because we're going to assume at the bottom, right, there's no energy, and at the top, when she stops, it has only EG. Okay, so we're not going to worry about the fact that it's moving. All right, so we're looking for the power. So that's going to be work over time. Okay, and we know that the work is also going to be the EG, because in order to go from nothing to EG, she has to do work on it. Okay, so the first thing let's do is let's find the EG of the bucket after it gets to the top. Okay, and the mass is going to be 12 kilograms. You're always going to multiply that by 10 newtons per kilogram, because this is giving you the force. And then the distance or the height is going to be 10 meters. Okay, so the EG that the bucket gains is 1200 joules. Okay, every single lifting problem works the same way. All right, so the power is going to be 1200 joules, and she does that in 5 seconds, which is going to mean she has a power of 240 watts to accomplish this task, right? Because remember, joules per second is what we call a watt, which is a measurement of power. Okay, right? So there'll be one similar like this on the test. Okay, so make sure you know how to do it. Yikes. Okay, all right, let's see how. Why does it always do that? I don't know how to get off of that. Okay, new. Okay, number 3. I'm not doing all of them. I'm only doing 2, 3, and 4. Okay, because 1 and 5 I don't care so much about. Okay, I'll give hints at the end for those. Okay, number 3. Hulky and Bulky are 2 workers being considered for a job at the UPS loading dock. Hulky boasts that he can lift. So here's Hulky. He can lift a mass of 100 kilograms, 2 meters up in 3 seconds. Okay, and Bulky says that he can lift a 200 kilogram box up 5 meters, and that takes him 20 seconds. Okay, which worker is more powerful? All right, so again, we're going to have to first find the EG, or the work that has to be done to get the boxes up to that height. Okay, so I'm going to do the same thing, the mass times 10 newtons per kilogram, okay, times 2 meters. Okay, so Hulky is going to have 20 times 10, 2,000 joules of energy, or he has to do 2,000 joules of work to get the box up there. Okay, Bulky, meanwhile, has 200 kilograms in his box times 10 newtons per kilogram, and he's going to raise it 5 meters. Okay, so he's going to go, what is that, 10,000 joules. So he's going to do 10,000 joules of work. Okay, right? Remember in the stair lab that we did, right, if they are the same mass and the same height, they would do the same work. Okay, that's how we did it in the stair lab. But in this case, there's different masses and different heights, so they're actually going to do different amounts of work. Okay, all right, so power is going to be work divided by time. Okay, so Hulky does 2,000 joules of work in 3 seconds, okay, for a power of 667 watts. Okay, and Bulky can do 10,000 joules of work in 20 seconds, and then so his power rating is 500 watts. Okay, so based on this fact, okay, Bulky did more work, but he has less power because it took him too much time. Hulky did not do very much work, but he did it very quickly, so he actually has a higher power rating. Okay, all right, similar to this, make sure that you review what we did on the stairs. Okay, I'll just give a quick reminder of that right now. Okay, if you had the walking and the running guy, right, the walking guy gets up, the running guy gets up. If they're identical, same mass, okay, and they get to the same height, then they will have done the same amount of work or energy to get there. okay? Because they're same mass and same height. Not like this. This, they were different, right? But in the stair situation, same mass, same height, they do the same amount of work or energy, okay? However, the runner is more powerful, all right, because he or she does that work in less time, right? So when you divide by a smaller number, that gives her a higher power rating, okay? All right, one more. Let's do number 4. Okay. Number 4, the trains on the Boss roller coaster are raised from 10 meters above the ground at the loading platform to a height of 60 meters at the top of the first hill. Okay, so some kind of thingy. It's going to start 10 meters high, okay, and then he's going to end 60 meters high. All right, so a lot of people in class were confused on this one. The total height that they were raised is only 50 meters because it started at 10 and ended at 60. Okay, that's going to take 45 seconds. All right, and the mass of the car we're going to assume is 2,500 kilograms. Okay, and we're going to assume all the work done goes into changing the EG. All right, so again, this is going to be the same thing. We just have to find the EG at the top. Okay, 2,500 kilograms times 10 newtons per kilogram times the height, which is 50 meters. Okay, that I'm going to need to get a calculator, I think, just in case. All right, 2,500 times 10 times 50, okay, is 1,250,000 joules, okay? And the time is 45 seconds. So when I'm looking for the power, I'm going to do the work or the energy gained, which was 1,250,000 joules, and that took 45 seconds, okay, which is going to give a power rating of 27,778 watts. Okay. All right. Okay, so a quick note for the test, okay? Either it's going to be like this or both, right, where you have to actually solve the EG, okay? But what if the problem was given and it said like a roller coaster or whatever was raised and it took, 200,000 joules of work to get there in 20 seconds, right? If it gives the original information already in joules, you don't have to do this, right? Because this is how I'm getting to joules. Sometimes the joules might already be given in the form of work or energy, okay? If that's the case, then all you have to do is just calculate it, all right? If it's already joules, don't do this. It's already done. It's already finished, okay? All right, and then quick hints for number 1 and 5, if you need them, okay? Number 1, you're going to convert first 700 calories, okay, and there's 4186 joules in a calorie. Okay, so the first thing you need to do is figure out how many joules it is, all right, and then it tells you it's 100 joules per second. You need to recognize this as a power rating. Joules per second is a power, okay, and then you can calculate the time. Okay, all right, and then number 5, the refrigerator, okay. It gives you the power as 500 watts, and the time is 200 hours, okay? But you need to convert this to seconds, right? Because a watt is a joule per second. So in order to use this unit, it has to be in seconds, okay? And then you can find out the energy or work, okay? All right, best of luck.